GBCSL, Board of Directors of the GBCSL, our distinguished presenters today, Engineer Harry LAI and Engineer Dr. Paul Sat, both from Hong Kong. Today's topic for the Green Talk is retrofitting and retro commissioning of buildings for green transformation, lessons learned in Hong Kong. I wish to make a statement by the great Mahatma Gandhi before we start this session. The world has enough for everyone's need, but not enough for everyone's greed. Ladies and gentlemen, before handing over the lectern to commence the presentation, I wish to extend a warm welcome to our participants, presenters, and on behalf of the Green Building Council of Sri Lanka. The Green Building Council of Sri Lanka is a consensus-based, not-for-profit organization which diverse and integral representation of all sectors of the property industry, environment, and academia. This was established with the joint efforts of the professional institutions of architects, engineers, structural engineers, town planners, quantity surveyors, university academics, construction industry leaders, environmentalists, and business leaders. Our vision is to transform the construction industry in Sri Lanka with green building practices and fully adopt sustainability as the means by which our environment flourishes, economy prospers, and society grows to ensure a future well-being of our motherland. To encourage dissemination and development knowledge regarding environmental responsible buildings practices, the building related industries to participate in public debate on environment issues within the building industry and green environment issues. These are some other objectives of the Green Building Council. We have training programs, green talks, which happen today, green walks, green ratings, and green competitions to select projects for green awards to encourage green practices. Dear friends, ladies and gentlemen, let me now introduce our presenters today. Engineer Harry LAI, Executive Director, Hong Kong Green Building Council. Engineer LAI received his Bachelor of Science degree in Electrical Engineering and Master of Science degree in Environmental Management, both from the University of Hong Kong. He is a Chartered Engineer, a fellow member of the Hong Kong Institute of Engineers, HKIA, and also the Institute of Engineers and Technology, IET UK. He has served as Chairman of the HKIA Nuclear Division, Secretary of the HKIA Electrical Disciplinary Advisory Panel, and also member of the HKIA Fellowship Committee. Engineer LAI is the Adjunct Professor of the School of Engineering and Environment, University of Hong Kong, and Adjunct Professor of Research Institute for Smart Energy, Hong Kong Polytechnic University. And our second presenter is Engineer Dr. Paul Sat, Head of Industrial Practices and Research of the Hong Kong Green Building Council. Engineer Dr. Paul Sat graduated with a BSc Honours degree in the Building Services Engineering and acquired his PhD degree in energy discipline and at the Hong Kong Polytechnic University in 2003. He joined Severe Properties Limited over 13 years and handled over 150 energy saving measure including both energy efficiency and innovative work. As the Head of Industrial Practices and Research, he worked together with the industry on promoting retrofitting, retro-commissioning, innovation technologies. His current interests includes energy assessment and benchmarking, knowledge-based energy management, big data analytic and diagnostic, etc. Also, I want to take this opportunity to thank my dear friend, architect Stephen Ho, who introduced me to the two great speakers today, who made this event happen. Thank you, Stephen, if you're there. Ladies and gentlemen, I don't take much more time. Let me now present to you Engineer Harry LAI and Engineer Dr. Paul Sat. Have a green and sustainable evening. Thank you so much.
Thank you for the very kind introduction. My name is Harry LAI. I'm the Executive Director of Hong Kong Green Building Council. I'm very delighted to have an opportunity to have this exchange opportunity with our counterparts in Sri Lanka, the Green Building Council of Sri Lanka. The topic that we are going to present today is related to the retrofitting and mutual commissioning of transforming green building and the lesson learned from Hong Kong. I must express my apologies because of the timing. I'm now actually in another event, so I cannot participate fully in the whole session. And then that's why I've arranged for my colleagues, engineer Dr. Paul Sett, to go through the presentation and with you, and then to explain the detail in the next hour or so. But I hope that it is only the opportunity to kickstart our relationship with your Green Building Council of Sri Lanka. And I did participate in the Asia Pacific Network of World Green Building Council. So I look forward to the opportunity of further collaboration with Green Building Council of Sri Lanka in future opportunities. With that, I hope that you have a fruitful and informative exchange tonight during this webinar, this technical talk. Now I'll hand over the time to my colleague, Engineer Paul Sett, please.
Okay, thank you, Mr. Lai. Okay, and good evening, ladies and gentlemen. Okay, my name is Paul Sett from Hong Kong Green Building Council. I would like to share one of my topics, famous topics, regarding the retrofitting and visual commissionings of the buildings for green transformations. Okay, lesson learned from Hong Kong. So what happens in Hong Kong for doing the retrofitting and visual commissioning? So that let's start from the energy efficiency and conservation. Okay, so that in here you can see there are 3 tiers. Okay, commonly we take this as a basic or principles for working energy efficiency and conservation. Okay, the base levels is which the energy fault remediations, adjustment, fine tunings, optimizations, and also modifications. Okay, so that at this basis we need to tune or to test whether our existing buildings, equipments, okay, or systems are properly functioned and also at good efficiency or not. If not, we need to tune it or improve it. Okay, and the middle one is regarding the energy efficiency. Okay, in here, okay, we can use another approaches, which is by means of energy management. Okay, we need to do some replacement. Okay, and also do some retrofit or renovations. Okay, but when equipments or systems becomes aged, okay, so they cannot fulfill their requirements. Okay, in those we purchasing before, so that we need to buy some new one or upgrade it. So that this is the tier 2. Okay, and in Hong Kong, we have some regulations regarding to this kind of exercise. Okay, so that the regulations is called the Building Energy Efficiency Ordinance. Okay, so that they need the developers or commercial buildings need to fulfill some of the minimum requirements regarding the energy efficiency of equipment and systems of the buildings. Okay, and the top tiers is tier 3, which regarding if you do very well, okay, in energy conservations and also energy efficiency. Okay, so that but you still need to achieve the carbon neutralities or 0 carbons in the coming futures, so that if you have already done the 2 tiers very well, but you still have some amount of carbons you need to remove, so that you need to take some offsets by means of the renewable energies. So that if the 2 tiers has already been done very well, so that you can do the 3rd one, the tier 3. Okay, this is the concepts of the energy efficiency and conservation. So that people may ask about what is visual commissioning or what is visual fittings. As I mentioned before.
Dr. Sett, are you screen sharing, or because we can see only you, not the screen?
Oh, okay. So that you can't see my screen?
No, we are seeing you only, not the screen.
Okay, let's try.
Yes.
Oh, locator.
Yes, now we can.
Yes, you can see here.
Yes.
Sorry. So all of you are that let me a little bit repeat that this triangle, as I mentioned before, that there are 3 tiers. Okay, the first, the basic tiers is energy conservation. Okay, which is regarding we call it the ritual commissioning part. So that in this part, people need to do some commissionings, fine tuning, or optimizations in order to improve the performance of the equipments inside the buildings. Okay, such as if like your home, if you do not require switch on the lightings, you need to switch it off. This is the behavior changes, okay? So that this is, we call it the ritual commissioning, okay? And the middle part is, we call it the energy efficiency. This is another thing, which is we call it the retrofitting or the replacement. When equipments are used a long time ago, they will deteriorate or they cannot work very well, or they need to upgrade, so that we need to replace a more efficient equipment or systems for the buildings. This is the tier 2, okay? We call it this kind of the measures. It's about energy management, okay? The basic one is the energy saving one. The middle one is the energy management, okay? And the top level, if both tier 2 and tier 1 are doing very well, okay? So that, but you need to still to offset some of the carbons in order to achieve zero carbon or carbon neutralities. Okay, so that you need to do something on tier 3, which is talking about to install some of the renewable energies. Okay, this is the basic concepts of the whole energy efficiency and conservation approach. Okay, so that people may ask in Hong Kong, what is the standing or the standards of the ritual commissioning, or what is ritual commissioning? Okay, so that in here you can see that ritual commissioning is a knowledge-based systematic approach for Hong Kong in order to check the existing building performance, okay, in order to identify some of the opportunities improvement for energy savings and also improve the indoor environments. So that you can see in here, ritual commissioning, this work, okay, composed of 2 parts. One is the ritual, okay, means energy, and the other is the commissioning, means testing and tuning. Okay, so that ritual commissioning is not ask people, okay, to replace or to renew something, but they ask people to do some of the commissioning or testing, tuning, okay, modifications, something like that. Okay, so that we can go back into the building life cycle. Okay, in the building life cycle, we do so many commissioning, no matter it's ritual commissioning or commissioning. Okay, and before the building is built, after the will hand over to the facility manager testing and commissioning in order to test the system's functionalities and performance. Okay, after that, the building is handed over to the facility management, or we call it the operators. Okay, when the operators receive the buildings, first of all, if the building is a green building, so they need to know the energy performance of the systems. Okay, if the energy performance of the systems is not very good, so that they need to do some of the ritual commissioning in order to fine-tune the performance of the building in order to meet the design of the green building. Okay, that is the first part. When the building is in operations, something may be changes. Something may be changes. For example, the operations may be changes, the tenants may be changes. Okay, from time to time. So that after the changes of the operations or the tenants, okay, we also need to do some commissioning in order to suit the tenants' requirements or the operational requirements. Okay, if the energy, if the commissioning is related to the energy, we call it the ritual commissioning. Okay, this is the second part when we also do some ritual commissionings for our buildings. And when the buildings is still ongoing operations, equipment or system may become deteriorations, and the performance will be deviate from the design. Okay, and also wear and tears may happen. Okay, And at this moment, we also need to do commissionings and also visual commissioning in order to ensure the buildings is operate at a good conditions and the energy efficiency conditions. Okay, and finally, okay, the equipment still have lifetime and they will fall down, and then we need to upgrade it or to replace it. So that in here we need also do the retrofit. Together with after the retrofit, we can also need to do visual commissioning in order to make sure that new system is operated as best as the design. Okay, and this kind of the cycle repeated in Hong Kong is around 20 to 25%. But sorry, 20 to 25 years. Okay. Okay, so that when the building is 15 or to 100 years, okay, it takes around 3 to 4 times. Okay. And here, this diagram shows that how the energy conservation and energy efficiency and conservation, or we call it visual commissioning and retrofitting, can be sustainable. Okay, so that in here you can see that a purple line is the design or the basics design of the buildings. Okay, when you move upward, okay, you need to want to upgrade the efficiency of the design, so that you need to take in the retrofittings, right? Okay, so that it will improve the system efficiency, such as what kinds of the retrofitting you may improve, you may do, such as to convert the air cool system to water cool systems, okay, to use direct drive, okay, to replace some of the high efficiency equipments, and also use the resilient technology, such as use some flexibility, more flexible control technology, something like that, okay. And in the when you downstream, okay, in below the purple line, okay, there is the problems, okay, when you operate the buildings. One of them is most of the people would over capacity or over design, okay, their system or equipment because they want to be play safe, okay, so that they would not just design just in time, okay, so that when equipments are over designed, okay, they will be not efficient, okay, so then we need to do some resetting and also replacement in order to make the equipment suit for this operation, okay. And also in normal operations, okay, because we have seasonal changes, we have operational changes, so that equipments may operate at not always at full load or at rated condition. They will operate at part load, okay? So that at this moment, we need to suit or to tune the equipment in order to make sure they operate at the most efficiency conditions, so that we also doing some reset and optimization approaches, okay? And also, in existing buildings, okay, equipments always have deterioration or their lifetime is not unlimited. They have limited lifetime. So that when buildings, equipment are deteriorated, okay, we need to do some maintenance and replacement, okay? And at this moment, we also need to think about visual commissioning, okay, in order to improve the performance or the efficiency of the equipment, okay? And finally, maybe some of the operations, the quality of the control operations may be not good, okay? For example, some of the sensors cannot meet the set point, okay? So that we need to do some, we call it the fault detection and diagnosis and also commissioning, okay? And all these things of the commissionings, optimizations, resets, okay, are related to energies. We also call them visual commissioning, okay? So that is the two way. One is you need to do some replacement or upgrade of the system or equipment. Another thing is that you need to tune and test, okay, and improve your performance of the existing equipments, okay. The later one is called the visual commissioning. The first one or the former one is called the retrofit. So the visual commissioning process, okay, in Hong Kong, it's divided into 4 stages, okay. They are called the planning stage, investigation stage, implementation stage, and also the ongoing commissioning stage. In the planning stage, okay, people need to collect data and information, do site inspection, understand the facility operations and requirements, something like that. Okay, this exercise help help people, okay, to be well planned their commissioning or their investigation in the coming time. Okay, so that in investigation, people need to do some data analysis and diagnosis in order to identify some of the saving measures or opportunities for doing virtual commissionings. Okay, and the third one is the implementations. At that time, people had already found some of the saving measures, and they need to do these saving measures in the existing buildings, so that they need to implement the saving measures, and also they need to conduct some, we call it the measurement and verification, to verify how many amount of the energy it can be saved through this kind of the testing and commissioning. Okay, and finally, this exercise in Hong Kong, people want, or building owners want it to be continuous. Okay, so that they need to review from time to time the exercise of how they implement the saving measures. Is the saving measures can be maintained through the lifetime of the buildings, something like that. If not, then we need to tune it again, okay, or modify it. Okay, so that this is kind of the exercise which can be done in the ongoing commissioning. And because there are so many things we need to do in the virtual commissionings, okay, we need to build the capacities of the industries, okay, to do this kind of the technical works. Okay, so that the Hong Kong Green Building Council has intended and had already set up a scheme. We call it the virtual commissioning training and registration scheme. Okay, in here you can see that we do some training and registration for professionals and practitioners. Okay, regarding the virtual commissionings. And also, we work together with different industry participants or professionals, okay, and also the governments, okay, to work together, okay, to motivate and promote virtual commissioning through the building industry, okay. And what kind of things we need to do? Most of the things we need to do is do some engineers, operators, and teach them and work together with them to improve, to test, okay, to fine-tune the existing services and systems, okay, in their buildings, okay. So that this kind of the things we come together to form a scheme. We call it the training and registration scheme. Sorry. Up to now, we had already over 2,000 candidates join this kind of the training, and then over 1/3 of the people or candidates had already become our R6 practitioners and professionals. Okay, and we also have 24 numbers of service provider. Those are the companies. Okay, that means we have 24 companies. Okay, that had already has this kind of the services in Hong Kong. Okay, we start this process since 2019, end of 2019. So it's around 3 years, okay? We can go up in this scale, okay? So that you can see in here. And we also, not our own effort, we also work together, so, okay, with so many professional institutions, such as the SIPS, the BSIMS is a kind of the O&M institutions, okay, in Hong Kong, and also some of the energy institutions, such as the AEE, the EI, something like that. And also we work together with our governments, the electrical and mechanical service departments of Hong Kong government, okay? So that under this scheme, okay, we divided, okay, the different practitioners into 3 levels. One is we call it the R6 level 1 practitioners, okay? This is the basic levels. That means it composed of numbers of the operators. So we call it the operational team, okay? And the other level is the engineering levels. They are we call it the R6 practitioner level 2. So that for operators level 1, for engineers level 2, and for those technical experts and leaderships, we take it as R6 professionals, okay? So that different people may have different roles in the virtual commissioning exercise or projects, okay? You can see that in here. You can see that for the operators, they need to facilitate the R6 process to complete or to deliver on site. And for the engineers, they need to do some more analytics, data analytics, and also identify the saving opportunities for buildings, okay? And also for the leaders, okay, they need to do some of the measurement and verifications and identify how many amount of the energy can be saved doing this kind of the things, okay? So the different levels with different role play, okay? And also, we also have some requirements. For example, they need to satisfy some of the qualification requirements, work experience, and also they need to complete the training and registration and the examinations that is organized by the Hong Kong Group Building Councils, and also they need to conduct some of the continuous professional development. Okay, and regarding the companies, we also have 3 types. Okay, the first type is the contractors, the MEP contractors. Okay, and then the role is to implement or the energy saving opportunities and do some site measurements. Okay, and the other level is the consultants. Okay, the MEP consultants. They do plannings, data analysis, and do verifications of the data. Okay, and finally, we also have another teams, which is the operators team. We call it the facility management. Okay, they need to do building operation and maintenance, and also the renovation of the building. Okay, when we do some of the visual commissioning. So that what is the concept of we develop this kind of the professional and practitioners in order to build the capacity for Hong Kong industry? Okay, first of all, you can see that in your left hand side, you can see that we want to grow a certain amount of the professional and practitioners in the industry, so that they need to have certain amount of qualifications, experience, and they need to take the trainings and examinations and complete the CPDs for Hong Kong. Okay, and the other thing is that after that, they can do some of the becomes our registered practitioners and professionals. Okay, so that we have about 2,000 candidates, and 700 is already become a registered professional and practitioners. Okay, and this kind of the professional and practitioners can be used by the building owners. Okay, they can employ it and as their own staffs, so that they can do the visual commissionings for their buildings. Okay, and another way is this kind of the professionals or practitioners can become some of the employees of the our service provider. We also have 3 types: type A, type B, and type C, regarding the building facility management companies, the consultant and contractors. Okay, so that the building owners can also employ this kind of the service provider, this kind of companies. Okay, to help them to do visual commissioning in their buildings, so that we have 2 ways. They can directly employ some of the practitioner and professional, or they can use those companies have this kind of the peoples to do visual commissioning in their buildings. And also in Hong Kong, the governments publish some of the technical guides regarding the visual commissionings, regarding these 4 steps or stages, which is talking about visual commissionings. And also they have some new improvements, okay, in 2023. Okay, what kinds of the new improvement? They want not only existing buildings do the visual commissionings, but also new buildings. They need to prepare, okay, their buildings to go for visual commissionings when the building is put in operations. Okay, and the other thing is that they also need, after major visual fittings, okay, the buildings also need to do some visual commissionings for those visual fitting works. Okay, this is 2 major changes in 2023. And finally, they also promote the IoT platforms or some of the smart technologies, okay, to adopt it for doing visual commissionings. Okay, this is the great changes for doing visual commissionings in Hong Kong. Okay, and in the future, okay, we can forecast that visual commissioning is not just a technology, but they can change the transform the industry into a more smart approaches, or we call it the innovation and technology approaches. What happens? Okay, in here you can see that we need to improve or increase some of the physical devices, such as the sensors, meters, actuators, equipments. Okay, then after we have so many this kind of the things, okay, and most of them may be wireless, okay? And then we can use this kind of the devices, okay, or the actuators, okay, to control the physical buildings. But in the meantime, we can capture all the data inside this device and equipments, okay? We have the data management systems, okay? So that when we want to do some of the measurement applications, okay, we can adopt this kind of the physical device together with the technologies of data management, right? After that, when we use this kind of data, also we can generate more energy saving opportunities by using some of the AI, artificial intelligence and machine learning technologies, some of the performance modeling or virtual reality process, okay? We call it the service integrations, okay? We can do it in these approaches so that we can generate more saving opportunities, and then we can use this kind of the platforms, okay, to tune up, use the technologies to tune up our physical devices, okay, such as those actuators and equipments, okay, and all these three things can be integrated together on we call it the services and commissioning platform, okay. This is a kind of the innovation and technologies approaches, okay. When we build up this kind of the projects, the first two-stage planning and investigation can be continuous, update and doing continuously. Then we can sustain our virtual commissioning process, okay? So that we can also have the ongoing implementation and ongoing commissioning, okay? This is a very ideal approaches, and we expect if the integration of the smart technologies, the integration of innovation and smart technologies, we can do it continuous and sustainable for those virtual commissioning works. Okay, so that this part I want to share is regarding the virtual commissioning. Okay, and the rest of them is we talking about the retrofitting. Okay, so that retrofitting, we issue a guidebook. This is the version 2. Okay, which is had already incorporated the version 1's technologies. Okay. This guidebook, retrofitting, okay, we also define what is retrofitting. Retrofitting also composed of two parts, retro and fitting. Retro means energies, and fitting means upgrade and installations. So that in here, you can see that we need to do some conversion or changes or replacement, okay, or upgrading. Okay, so that we also divided different types of the saving measures or energy management measures, okay, into different level of the system, such as for commercial, we can talk into about air conditioning, water side, that means the chiller plants and also the air side systems, electrical systems, car park ventilations, lift and escalators, smart control systems, and also heating and building envelopes, okay. We also have some technologies focused on server room or data centers, and also some for kitchen appliances. Okay. So that we will talk about one by one in the rest of time. Okay. So that for air conditioning, water side, we talk most likely in Hong Kong, they have both air cool and water cool systems. Okay. As you know, that's water cool systems may be more energy efficient than air cool. Okay, and for the water cool system, they also have two types. One is the fresh water, the other is we call it the indirect seawater. Okay, because seas are surrounded in Hong Kong. Okay, and the air conditioning objective for doing retrofitting, we have these following points. One is to improve the efficiency of the chillers. The other is to relax the compression requirements. Okay, that means because as you know that air conditioning is come from compressed refrigerant, okay, and relax them. So something like this kind of exercise, so that the compression requirement can be not stringent. Okay, we want to relax them. Okay, and the third one is to minimize the pressure and flow of the pumps, and also minimize the speed of the cooling towers, and also optimize the system performance by adopt some of the smart technologies. Okay, this is the objective for the water side. So that what kinds of the strategies or technologies we are now using for? Okay, First of all, this is very common. Replace the chillers with a more efficiency one. Okay, so then in worldwide, there are some standards come from the SAs. They're talking about different types of the chillers. What is the required COP or recommended COPs for this kind of the chillers? Okay, so that we can follow this kind of the requirements. Then if your chillers has already been deteriorated or downgraded, so that you can replace it with a better efficiency one. Okay, this is very common. Okay, and the second one is to convert the air cool system, okay, into the water cool system. So that by conversion, most likely in Hong Kong, okay, we do not do air cool directly converted to indirect seawater cool because it is too expensive. And also, you need to, the site has some constraints. The site should be very near the seashell, something like that. Okay, but most likely we can use or add the cooling towers in order to use freshwater cooling. Okay, this is quite common in Hong Kong. Okay, to do the conversion from air cool to water cool. Okay, so that for air cool chillers, the COP or the efficiency is around 2.5 to 3. The higher the COP, the better the chillers. Okay, so that when we convert it to water cool, the COP will be up to 5 to 6, something like that. Okay, and the third strategy is talking about we use the variable speed cooling towers. Okay, and this technology not just change the cooling towers to variable speed, but we also need to increase the numbers of cooling towers. You can do a test to see that if you use 4 cooling towers at full speed, okay, you may achieve the condensing water entering temperature to 29 degrees Celsius in Hong Kong. But when you use more cooling towers, such as NOx 4, you add 1, you use 5 cooling towers, but you can reduce the fan speed of the cooling tower. You can have a much better or lower condensing water entering temperature, such as 28 degrees Celsius. Okay, so that if you use more cooling tower but at a lower fan speed, the total amount of energy consumption may be lower than that of you use less cooling tower but at greater speed. Okay, this is the practices we have already done so many times before, and this is quite successful. Okay. Another one is some of because Hong Kong Hong Kong is there is no the fresh water for Hong Kong is soft water, not hard water. But I know that most of the countries or cities in other countries the water is hard water. So that calcium carbonate is a fouling contaminants. Okay, they always affected those systems using fresh water. Okay, so that they would use the tube cleaning, or they could have used some of the electromagnetic clamping, okay, to some of the pipe works, okay. So that this kind of the actions, for example, if you're doing automatic tube cleaning, there's some spongy balls, okay, that can be running along the condenser tube and clean those foulings or the calcium carbonate, okay. And also you can use the magnetic flux, okay, to improve or to change the ionization performance of the waters, so that the carbonate is not easy to form or attach to the pipe. Okay, and in Hong Kong, the carbonate effect, the calcium carbonate effect is not too serious, but the water quality effect is much serious. Okay, especially when you use cooling tower, because the air quality in Hong Kong is not very well compared with some of the other countries. Okay, so that there are so many ducts, okay, inside the air when they wash, okay, by waters in the cooling towers, they will create some foulings in the system. Okay, so that when we are using cooling towers, we also will consider this kind of the things. Okay, so that if we use this kind of the things, we can remove cooling towers. The condenser water can be lower, the temperature, the leaving temperature can be lower. Okay, and then we improve the compression ratio. okay, of the compressors and improve the saving. And the fifth one is the variable flow. Okay, we can do it by convert the constant speed bump to variable speed bump. Okay, and also we can convert the second one is the system. We can convert the constant flow system to variable flow system. Okay, I think this tool is quite common, especially the first one. Okay, most of the people, I think in other countries also convert some of the constant speed devices into variable speed. Okay, the successful parameters is how you can control the speed of the devices. Okay, and we have one examples later talking about the second one, to change the decoupler systems into the we call it the variable flow system, or we call it the variable primary flow system. And the next one is the we use the inline pump. Okay, as you know, that's in conventional air conditioning flow control, mostly they use control valve, but there's so many problems in using the control valve. One is they will create a very large resistance. Okay, when the flow rate requirement is very low. Okay, so that people may talking about using some of the discharge pump or this inline pump. Okay, for specific zoning or equipments. Okay, the second one is that we can divide it for large scale systems. We can divide it, the circuits, okay, into different sub-circuits, and we can use different variable speed pumps, okay, at different capacities to treat each systems. So that different systems, no matter the scale is large or small, they can have their own pressure requirement. Okay, we do not confuse it. Okay, so that they can optimize the pressure head requirements for each circuit. And the seventh one is we also use the pressure independent control valve. Okay, in conventional, most of the control valves is pressure dependence. Okay, we use the temperatures to control the valve opening. Okay, if you meet the set point, then the valve will be closed. If you cannot meet the set point, the valve will be open for cooling, something like that. But now, in recent years, okay, people develop some kinds of the flow controls valves. Okay, they call it the pressure independent control valve. Okay, in short form PICV. Okay, and this kind of the valve, they do not use directly the temperature to directly control the valve open. Okay, they would use in parallel with the control valve. The control valve can use the flow rate, okay, to control the valve opening. Okay, so that when you use that, the benefits for this kind of the control is that the valve can be operated in a very low flow condition. Okay, as you know that if for existing buildings, okay, in Hong Kong, in summer and winter, the cooling load requirement is the ratio is let's say 1 to 5. For example, in or 1 to 10. In winter is 1. In summer is 5 or 10. 5 times the dose in winters, something like that. So that only a very small amount of flow rate is required. But if you use the conventional pressure dependent valve, you cannot achieve this. Okay. So this is the water side. And for the air side, the objective is also, we also have the constant air volume system, variable air volume systems, and also the air water system. Air water system means the fan coil unit system. Okay. And the objective of this air side is to reduce the fan power, cooling load, and increase the motor efficiency, and also reduce the air duct loss, frictional loss. Okay. One thing is that we want to convert the conventional fan coil units. Okay. They use some of the conventional mechanical or the valve control, the feed speed control for the fan coils, something like that, into we call it the iFan coil or a smart fan coil unit system. This kind of the fan coil unit system, they use the variable speed motor, the DC motors. Okay, and also they control the room temperature, not only by using the solenoid valve, they also use the fan speed. So fan speed and valve together to control the space temperature. Okay, and the benefits is that when you use both parameters together, okay, and most of the times the fan speed can be lower. Okay, in conventional one, you need to do it manually, but most of the people would not activate, okay, the fan speed, and the control of the temperature is not precise. Okay, this is the problem. Okay, so that when you use the smart fan control unit systems, you can improve or save about around 14 to 15% of the energies, okay, of the ASI system. Okay, and the other is they use some of the air filters with low pressure drop. So you can see that in here. So, okay, when you use the low pressure drop filters, the original one is, let's say, 17 PA, the Pascal. Okay, but when they use the low pressure one is around 13 Pascal. This is the new filters. Okay, so that the pressure drop is not hundreds. Okay, it's only 17. And but we use the low pressure drop one is only around 1/3 to 40% savings in the pressure drop. Okay, this is very significant. When you put it into the systems, you can reduce the air fan pressure head requirement. Okay, and another very common in recent year in Hong Kong is to convert the belt drive centrifugal fan or for both air handling units or the primary air units into we call it the electro communicated EC, we call it the plug fan. This fan is they would not require bell. Okay, it's direct drive. First one. The second one is that they are using the direct current, so that when you want to change the speed of the fan, you need not increase or you need not to install frequency inverter. You can direct changes the currents and voltage, okay, of the power directly, so that you need not require to install frequency inverters. Okay, and the third one is that this kind of the fans has better efficiency, fan motor efficiency, we call it. Okay, and also the power performance. Okay, they can reduce the speed much lower than those belt drive centrifugal fan. Okay, so that this is also very common. The amount of saving is around 13 to 50%. Okay, it depends on the usage, okay, of the fan. Okay, this is also quite common in most of the luxury commercial buildings in Hong Kong. Another thing is that when we want to in mild season and winter for Hong Kong, okay, but the restriction is the opening of the fresh air opening. Okay, so that in some of the buildings they enlarge the fresh air opening. Okay, and they also in summer we do not want use so many fresh air because it consumes energy. Okay, but in winter when the outdoor temperature is low or the humidity is dry, so that we can want to capture more air, okay, into the space for cooling. Okay, so that in here you can see that they have ductwork. Okay, it is the conventional design, and also they enlarge the openings of the outdoor so that they have larger openings. Okay, when the mild seasons or winter conditions is good enough for free cooling, we call it the natural ventilation. So, okay, so that they will open this kind of the opening. Okay, instead of using ductwork. Okay, but in summer they still using ductwork for cooling. Okay, this is the things we need to modify. Okay, the openings of the building envelope. Okay, or we need to do it when we construct new building. And the fifth one is also very common. Okay, is to convert the constant air volume system to variable air volume system. Okay, and this is when you do the conversion, the most serious point is that you need to install the variable air volume boxes, the VV boxes, okay, in the ceiling void. Okay, it depends because I see that some of the buildings, if they have open plan office, okay, they may not require to install so many or to install the whole VV box to the whole floor. Okay, the VV box only using in those meeting room or boss room, something like that. Okay, for open plan office, they can just convert the system to using the air handling units with variable speed fan. Okay, and at this condition, they not use the VV box to control the volume. They use the return temperature. When the space achieve the return air temperatures set point, the fan speed can be reduced. Okay, they also need to take into account those common area and also those meeting rooms together. Okay, when they reduce the fan speed. Okay, but when you use these approaches, you can reduce the usage of numbers of VV boxes. Okay, and can save significant amount of money. Okay, and another one is that they use the fan coil unit system together with the PAU systems. Okay, and the fan coil system, they only use it to cool, to do sensible cooling. They do not require do dehumidification for the fan coil unit because dehumidification for fan coil units is not well performed. Okay, and by using these approaches, okay, the latent load will be covered or will be catered by the fresh air unit or the primary air unit. Okay, so that the primary air unit, they have some desiccant dehumidification system installed together with the cooling. Okay, so they will treat the fresh airs, okay, to ensure the humidities of the space is good enough. Okay, and for those coolings, okay, for those internal loads such as the equipment load, lighting load, okay, and also the sensible load of the occupants, something like that, they will use the fan coil units. And one of the benefits for doing this way is that they can increase the supply water temperature, the chill water temperature, okay, of the fan coil unit, so that the chill water temperature increase, the compression requirements of the chillers can be less and become more efficient. Okay, so that they can use this kind of thing. Okay, this kind of thing similar to what I'm talking about in latest radiant cooling. Okay. And another thing is most likely they use in wet markets or the markets in Hong Kong. Okay, they want to do some of the pre-cooling for the hot fresh airs with the cool exhaust air. What kind of technology they use is called the indirect evaporative cooling. Okay, the difference between the thermal view and indirect evaporative cooling is that they use the evaporation to cool the air instead of only use the temperature. Okay, in here you can see that the primary air or the fresh air passing through a thermal view. Okay, and let them out. Okay, and the return air, okay, also pass through the thermal view and then let them out. But when they pass through before they pass through the thermal belt, they use the water to do evaporative cooling for those return air. Okay, and use this kind of the return air temperature, okay, to cool the intake of the fresh air, so that this is more effective than thermal view. Okay, and also if the primary air is become more cool and dry, like those in winter. Okay, so that they can use the regenerative mode, okay, to directly use this kind of the cooling to cool the primary air. Okay, this is the regeneration mode and this is the general mode. Okay, this kind of the technologies most likely used in some of the areas that is not require as very precise space temperature and very large amount of the cooling, such as those in wet market, something like that. Okay, so that in Hong Kong, the housing authorities markets, okay, may using this kind of the technologies. Okay, we have a demo or a showcase in latest. And another thing is that we can use the fresh air demand control. This is very common because in hot summers, when you intake the fresh airs for occupants, for breathing, you need to cool down the fresh airs. In order to minimize these cooling energies, you need to do some demand control that to limit the amount of fresh air intake in summer. Okay, but in winter, the air become cool, and this is a cooling sources. You can use this kind of the cooling sources to cool the systems. And this another strategy is the radiant cooling technologies. Okay, this kind of the radiant technologies is a passive system. Okay, we can use it without using the fan power, so that this kind of the things is very energy saving or energy efficiency. But the disadvantage is that this kind of things mean the response rate or the response is quite slow. Okay, when in mild season and winter, this is very good. But in summer, this is not perfect. Okay, so that in summer, we can use the primary air as the cooling media. But in mild seasons and winters, we can use this kind of the technologies, the radiant cooling. Okay. Another thing is spot coolings. In some areas, also we can use the high volume, low speed fan to increase the air changes in order to raise the space temperatures. Okay, so that you can also save the cooling energy by a means of using more fan energy. So that air conditioning is something like that. For electrical, okay, we're talking about three things: lighting, electrical distribution, and lift and escalators. For lighting, okay, we can want to optimize our layout in order to adopt more daylight, so that you can see that when you leave the spaces for those spaces for those areas nearby the windows, okay, you can have better daylight penetrations to inside. Okay, and also for those areas you have skylights, you can also those spaces underneath the skylight as some of the meeting areas, something like that. Okay, occupant sensor, I think it's very common. So okay, people walk in and the lights on, people leave those particular areas lights off. And also in recent years, they use some of the smart control technologies to control the occupant sensor, to control the lightings for the general lightings for each occupant's desktop, something like that. And also, we in our office, we also use the task lights. Okay, for example, in nighttime work, we only use those task lights and also the general lightings on top of our head. Okay, we do not the other areas with the lightings switch down, something like that. And also another thing is that we replace those fluorescent tip T8 or T5 into the LED lightings. Okay, and for the electrical distribution systems, we use some of the cap band harmonic filters, improve the power qualities, which is quite common to control the power qualities. And also we can install more smart lightings to capture the data to do more data analysis in order to find more saving opportunities. Okay. For lift and escalators, we can use regeneration powers. Okay, when the lift is going downward, something like that. And also, you can do some modification for those H lifts because most of them, after the modification, most of the machines have already been improved and the efficiency and already upgrade. You should have some savings for this kind of things. Okay, and also we can upgrade the lifts to use some destination control. That means the button, okay, the lift button is outside the lifts, not inside the lift. Okay, so that the computer can assign the numbers of the lifts to optimize the number of travel between lift or lift car. Okay, so that you can save amount energies. And we also need to reduce the interior decoration rates inside the lifts And also we need to modelize the escalators by means we can use the variable speed control for escalators instead of the constant speed. And smart technologies, okay, very common in recent year, okay, the IoT technologies, okay, this is that first of all the benefits is wireless, very convenient plug and play devices, and also we can install so many software or mathematical models, data management systems, okay, into the platform, so that they can become more intelligent, the platform, okay. And the other thing is the visualizations of the data. Okay, this kind of things can help the sustainable development reports. Okay, to become visualized and also data manageable, so that senior management and also bank can make use of it to produce green finance for the building activities. Another thing is the artificial intelligence and also the machine learning. Okay, we can use this kind of the technologies, okay, to optimize, okay, the building operations, okay, by use the we call it the digital twin. That means we build a virtual models, okay, which is very similar or identical to the physical models, and we can tune up the virtual model and ask the physical model to learn from the performance of the virtual models in order to improve the efficiency continuously. Okay, and also we can use the people counting devices, okay, to provide more informative solutions or informations, okay, to control the air conditioning, lift and escalators, something like that. These kind of things are also called the smart control. And regarding the server room, okay, we can use some of the high efficiency UPS systems, okay, with very, very good power factors. And also we can use the hot and cold ISO for the data centers, okay. In here, you can see that the cold ISO should be enclosed, okay. Inside the cold ISO, the air temperature is around 21. Outside it is around 30, so that there are great temperature difference, okay, between cold aisle and hot aisle. Okay, this is the correct design. Okay, I see that some of the things is that if you do not enclose the cold aisle, so that all the space are already become 21 degrees Celsius, this is not effective. And also this is not the hot aisle and cold aisle design. Okay, so that when you do this kind of the design, you need to do and close for the cold aisle. And another reason recommended to use this kind of the fluid. Otherwise, you cannot use this kind of technologies. Okay, so that the restriction of this kind of technology is that if the computer master board is not recommended for using this kind of technology, you cannot use it. Okay, so that another thing is comes out is we call it the fan wall, we call it or the cold door or something like that. Okay, so that in here, instead of to cool the cold aisle, okay, you can only use the cooling to cool the exhaust hot air, okay, by use this cooling coil. And then after they cool the air, they direct inject it to the space, and then we use for cooling this rack. Okay, so that this is we call it the cold door. Okay, is very latest technology, and when we use this kind of the technologies, we can reduce the space for the data centers. Okay, then you can have so many rack for a same space. Car park ventilation. Okay, we can have a good zoning for the car parks. Okay, to divide it is better. This the car park railway and also the parking area, something like that. So we can design the better airflow control for the car park. And the other is that we can using the induction unit, okay, instead of using ductwork, okay, induction unit can do the displacement ventilations, okay, without using the ductwork, and then we can save the ductwork pressure drop. And for some kitchen, okay, they use some of the heat recovery kitchen appliances, okay, so that when some of the waste heat comes out, they recap the waste heat, okay, to heat up the waters, so that the waters may become preheated before they directly boiled by the boilers or the fuel, something like that, okay. And the other thing is that we also use the heat recovery chillers or heat pumps to provide instantaneous cooling and heating together. For the building envelope, okay, we can use the light shelves or the solar reflect bind together, okay, to capture more daylight into the space. Okay, we use the revolving doors to prevent infiltrations, okay, inside the buildings. Okay, when the weather is cool, we're also using natural ventilations, okay, for some of the shopping mall. Also, we use some of the coatings, okay, for the roof or for the pipework, something like that. Okay, this is the roof. So that you can see that when do the coatings, the I-paint, the space temperature is around 32 degrees Celsius. Without it is over 60. Okay. And also we can additionally install some of the shading device in the outer layers, okay, of the building facade. Okay. And also we can do some of the green roof or green wall in our buildings. We can use some of the ventilated facade so that in summer and winter, okay, in the air, in summer, the air is passing through the windows and rejected to the space to reject the heat kept enclosed inside the between the facade. Okay, but in winters we can want to encrypt or make use of the air within the facade into the space. Okay, so that there's some of them is mechanical, some of them require to have some fan to inject air. Okay, together with the openings. Okay, between the envelope, the building envelopes. And also we can add some renewable energy, something like that. This is some of the design, the building envelope. As the renewable, the PV is installed on top of some of the glazing. Okay, and also some new technologies, they're using the algaes to produce energies. Okay, and this is another kind of the PV they use. Okay, and they can adjust the angles of the PV in order to maximize the daylight penetration, and also the solar, the electrical generation. And also we can use the PV together with the green roof, something like that, to optimize this kind of the improvement. And also in here you can see that we can use the solar frame to reduce the solar energies, or you can use some of the painting to paint in the condenser pipe to reduce the water temperature of the condenser water. And this is all what I say about the strategies. And we can do a very quick, I know that the time is gone, we can do a very quick to show some of the showcase. The first showcase is they replace this building, they replace the existing, the very old fresh air fan, okay, into a primary air units. And they integrate demand control together with the primary air units. The benefits is that in conventional control, they would induce so many fresh air into the buildings and also to increase the heat load, the cooling load. But when you use the primary air unit, the pre-treated cooling for the fresh airs together with the CO2 demand control, they can minimize the amount of the fresh air, and also you can do free cooling in winter or mild seasons. And also to reduce the cooling load demand in summers for occupants. this is the designs for a markets, okay, in the housing or residential centers, okay, of a wet market, okay, they're using the indirect evaporative coolings, okay, so that you can see in here, this is the thermal bill together. This is the humidifiers, okay, to use evaporations to further cool down the return air or before they exhaust from the buildings to cool the primary air, so that this is more effective. Use evaporative cooling. Okay, this is their setup. Okay, so one of the disadvantages, they need a quite large mechanical spaces. Okay, when you're doing this kind of things, this is the disadvantage of this kind of the technologies. Another thing, the showcase fee is that to convert the primary, secondary, or the decoupler systems into a primary variable flow system. Okay, so that in here they can use bypass the primary circuit. The primary circuit, they can use a bypass pipe. So okay, so that because the secondary circuit is variable speed, you just add a bypass pipe, okay, in here, so that the system will be turned out into a primary variable flow system. Very easy. Okay, if you don't want, or you need to reconvert it to the original one, you just use a isolation valve to isolate this bypass pipe. You can activate this kind of circuit. This is very easy, and you can reversible. Okay. And also, these cases, they also install so many sensors and analytic devices so that they can analyze and verify the amount of saving when they are doing in this way. Okay. And this is they use the heat pump instead of the heater, the tank gas heater. Okay. Original, there are 1,014 amount of or 24 kilowatt tank gas heater. But they use a 2 heat pump together with 3 storage tank and 3 storage heaters. Okay, total together there are several hundred kilowatt instead of the over 1,000 kilowatt, so that the amount of saving is largest. Okay, and also the heat pump can also produce some coolings together. Okay, with additional cooling. Okay. So that the paper period is quite sensitive. It's 4-something years. And the showcase 5 is talking about the building envelope. This building has only 1 layers, okay, of the facade of the glazing. Okay, we can add a double glazing insulated glazing at the internal areas. Okay, this is the internal, this is the external. Okay, you can add a double glazing. This is a 2 layers glazing. Inside these 2 layers is a vacuum, so that this is a vacuum, very thin. Okay, but the performance is very good. Okay, so that they can reduce 10 to 13 amount of the energies. Okay, penetrate through the windows. Okay, and also the amount of OTTV, overall heat transfer thermal transfer value, will be dropped by 70%. The drawback is that this amount of layers, okay, can slightly reduce the light penetrations, okay, to about 20%, something like that. Okay, this is not very significant. Okay, this is the installation, but it's also very easy, very fast, something like that. And another showcase is the filters. Okay, this kind of the filters. Okay, you can see that they use the low energy air filters. Okay, instead of the P filters and BEP filters. Okay, so that you can see that the particular count is reduced. So that use this low energy air filters, you can have better filtration performance. Okay, and also the pressure drop is from 121 PA to half 52 PA, something like that. So that the paper is very fast. Okay, and the investment is not too high. And another showcase, I think, is maybe the final one is we can use install external facade, okay, to the original buildings. Okay, this is quite expensive, but the purpose of the installation may not be energy saving. There may be some requirements, such as for in this building, they are using white tile and red stone. It is very old design, so that they want to make their buildings much more cyber, so that and also easy for future maintenance. And also, this kinds of the installation, they have their own gutters, okay, and allow the tenants would not would not produce so many distributions to the tenants, okay, so that this is very fast to install that and very easy to install separately for each tenant, okay, so that they do these things. And they're using the low E alarm light gas in here, so that you can see that this is the layers, okay, the newly installed, and also they use the aluminum cattings and steel structures, okay, to fix this kind of the glazings, and also install some of the LED lighting to make the overall performance or the overall outlook of the building is very cyber. Okay, this is the main purpose. Okay, but the side benefits is that the ODTV can be substantially reduced by using the low E laminar glass. Okay, and this is also the benefits. So this is all the showcase and visual fit elements and items we want to discuss with you. And if you have any questions, we are a little bit over time to around 10 minutes. Okay, so sorry for that. Okay.
Thank you very much, sir, for sharing your valuable knowledge with us. So we have come to the Q&A session of our Green Talk now. If you have any queries on this session, you can raise your questions now.
And also, I think the PowerPoint can be shared with all of yours.
There is a question on the chat box.
The chat box, which slide?
I can read the question. What are the challenges in adopting this approach in the field from your experience?
Okay. The problem is that one of the very typical problem is that the information and data we need to, when we're doing the energy efficiency improvement for buildings, one of the very important things we need to make use of the data to verify and to understand how many amount of savings or why they can save so small or so large. Okay, and even in Hong Kong, okay, most of the buildings may not have sufficient data, okay, to do this kind of very detailed studies on the visual fitting or visual commissioning projects. Okay, so that innovation and technology approaches using smart sensors or the IoT technologies, okay, Internet of Things technologies, okay, is a way forward when we're doing this kind of the improvements. Especially people's much more concerned about the amount of savings or different savings between different buildings. Okay, so that we need to do use some smart technologies. We need to enhance our instrument or the sensors and meters, something like that. this is also the Hong Kong governments and also the building industry in Hong Kong need to take challenge for this kind of things when we're doing the saving. Okay, another question is that I've already do this kind of the things 25 years. Does this mean that the emission or retrofit has to be recovered within 25 years? Actually, most of the retrofit had already the payback of this kind of the retrofit should be less than 10 years, okay, or even 15 years, even though those new technologies, okay. The amount of saving, larger or small, it depends on the qualities of the control and also the qualities of what you do for the buildings or what you do for the improvement measures. Okay, so that if your buildings, okay, have better status that can be captured from the systems, okay, and you understand better, okay, for this kind of things, your payback can be a little bit shorter, because some of the people, for example, when you do the tuning or to do the reset, or for example, to reduce the pressure, to reduce the flow, people always afraid that the flow is too low, the pressure is too low. Why? Because there's insufficient amount of data to tell them, okay? So that they only just tune a very small amount. They just use a very not effective devices, something like that. Okay, this is not a good approaches. Okay, if you want to save more in order for the same amount of money produced, okay, you need to have so better use of the data. Is the retrofit mandatory? The retrofit is not mandatory, but Hong Kong governments have regulations to convince the people need to do retrofit. But do one retrofit or do 10 retrofit, okay? Or you need to save 5% or 10% per year. There is no not mandatory in the regulation. And also it's difficult to maintain, okay? Do the coating difference from interior side of the glazing to or from the exterior side of the glass to interior? Yes. Which side is better? Okay. Most of the people say that external is better. Okay, because if the insulation directly, the solar directly hit to the windows, okay, and when you have the some of the coatings and in the exteriors, you can directly reflect or prevent it penetrate into the internal. Okay, so if the frame is, or the solar frame is inside the buildings, is may not be better than it is outside. But the drawback is that when you coat the coatings in the outside, weather impact is another problem. And what kinds of the analysis will be undertaken to assess the successful of the system design for the existing buildings? Okay, what is the percentage of design accuracy compared to the actual result after the installation of the system in the existing building? Okay, mostly we do the measurement and verifications for those energy saving projects. We are using, we call it the regression analysis. Okay, I think is in 20 years before, regression is ready to use in the industry. Most likely they use in the university. Okay, but I think in the recent 10 years, regression is very common being used in this kind of the visual commissioning or visual fitting measures. Okay, the benefits for using regression is that because you cannot compare, you cannot find the identical weather day for different days or years. Okay, so for example, if today the weather is the temperature, the outdoor temperature is 25 degrees Celsius and the average is 17. Okay, after you do the measures, okay, the next day, but the next day you cannot actually is 25 and 70, right? So that regression can do this kind of the normalization, okay, so that they can provide a better comparison, okay. But people always use today I do something and next day I return it and then we check and then we also repeat this today and next day. It is not accurate, okay. Even though if when we are also see that in some scenarios such as in those COVID-19 situations, okay, the variation of the loadings due to the occupants is very significant, and we cannot easily to find some identical days to compare, do it and not do it, something like that. Another question is that Hong Kong has limited area. That may be the reasons for many high-rise buildings. Okay, what is your advice for your countries to go for high-rise construction in terms of the sustainability? Okay, this is a good questions. Okay, and I also do some of the studies. We in these 10 years, because when countries, okay, the economic growth or expand rapidly, most of the countryside or most of the landscape will become a city or a urban, okay, that can sustain their economic growth, right? So that we call it complex cities is a long, okay, for those developing countries and becomes a developed countries, right? So that in these approaches, when the population increased, people should be increase their building height, okay? But you can increase the building height, the space, the spatial requirement or separations between buildings, or we call it the building proportions, something like that, or the propagation, something like that. That means the height profile of the buildings from seashore to inland, okay, should be very clear to consider, okay. And also we need to do much more passive design for new buildings, something like that. Otherwise, if you do the whole cities same amount of height and very packed, it is not efficient for the development of a complex cities. Okay, so that I think this is the point that Hong Kong looking for this kind of the technologies around. I think it's around 15 to 20 years before. Okay, and very earlier there's no more this kind of concept. Okay, so that when you do the redevelopment of some of the districts, okay, the governments and also the industry need to review this kind of the things. Could you please share some buildings that are successfully implement retrofit practices in Hong Kong? Okay, I think most of the because in Hong Kong there's some of the luxury commercial building, we call it the Grade A buildings. Most of the Grade A buildings in some of the famous building developers, okay, they do so many retrofitting or even visual commissioning year by year. Okay, and the amount of saving they can achieve, okay, under our record, because we have a carbon zero ready carbon shot, okay, and we are now around I think around 15 numbers of buildings have already got this kind of shot, And the higher rating is they can save around 45% of savings from the norm of the energy consumption intensity of the buildings in Hong Kong. Okay, so that the norm means that 50% is the norm. Okay, they can 45% lower than this norm value or the normalized value, or in terms of the building energy intensity. That means the kilowatt hour per square meters per annum. Okay, so that most of this kind of buildings can do this approaches. Okay, in Hong Kong. Okay, it depends your investment and also the how long you continue to do the retrofitting and retrocommissioning. Another question is, thank you for the insight presentation. I have done my final year's dissertations on sustainable retrofit of office buildings in one of the districts in your countries. While doing the research, I identified that there's a very effective strategy to reduce the energy use of existing building. Do you think that there can be a template design strategies that can be created for building with different climate zone? Yes, for buildings, for countries, there may be some because Hong Kong is very small. Okay, so that there's no different climate zone for Hong Kong. Okay, for those large countries, okay, they should have, even though China's, US, they also have different climate zone. Okay, so that you can see my PowerPoint or especially for Hong Kong, most of the buildings are concerned about the cooling instead of heating. Okay, because the whole years for Hong Kong, unless the outdoor temperature is below 18 degrees Celsius, otherwise most of the buildings is in Hong Kong, they're doing cooling. Okay, only around I think less than 1 month. Okay, the temperature is below 18 degrees Celsius. Okay, in Hong Kong, and this scenario is become worse because climate change impacts. Okay, the ambient temperatures for Hong Kong will be rise from time to time. So in Hong Kong, there's no many months or days is a winter. Okay, so that because you can make reference to those China and United States, they have different strategies for different buildings at different climate zone. Okay, you can make reference. Okay, for example, HKGBC have some design guide for different types of buildings. Okay, they can publish. And in the public domain, you can download it. Okay, so that you can make reference to these kind of things. And in China's, okay, you can buy some of the guidelines talking about the high efficiency buildings design. Okay, they also have these regulations for buildings, and also in China's they also have climate zone for different regions. Do you encourage district cooling system? Yes, this is also a very interesting question. Hong Kong also has district cooling. Okay, why? It depends on how you compare district cooling. Okay, when you use air cool, okay, and when you converted the air cool system to district cooling, okay, this is very variable and high efficiency. Okay, and I also understand that if you had already using direct freshwater cooling, such as the cooling towers, to do the chiller plant, okay, district cooling may not is a effective way. Okay, but if you provide cooling for a district, and inside district you may have some hotels, some residential buildings, some commercial buildings. Okay, district cooling have a better performance than non-district cooling system. Okay, so that is district cooling always true? It's not always true, or always energy efficient. Okay, but if you directly compare, because when you're doing district cooling, you will not construct a air-cooled district cooling plant. Okay, you should convert it. You should do a water cool, or we call it the indirect water cool district cooling plant. Okay, so that if you compare air-cooled against the water cool, because when buildings most likely developed or constructed in the inner areas of the landscape, okay, the intent to do it in air cool is higher. Okay, so that's why district cooling is benefits. If they can serve some of the building in between the inner and the near the seashore, so that you can have some benefits. Okay, but district cooling, if you do a better water cool systems, okay, these systems may have a higher performance than district cooling. Okay, so that you can see that your question is talking about mega city, and mega cities, and most likely if you do a district cooling, they can improve the ratios of the air to water cool of all the buildings. That should be a slightly benefits. Okay, but if in Hong Kong, I'm not sure whether it is so if you can you have improvement if you do some district cooling plant. But when Hong Kong continues to develop, to build so many district cooling plants, I think that is not a good way. So that is, I think that is what your questions. I'm not sure whether I can answer all the questions. Okay.
Yes, sir, you have answered our questions. So every good thing must eventually come to an end. As it is, we have reached the end of this event. On behalf of the Green Building Council of Sri Lanka, I would again thank our guest speakers for sharing your valuable knowledge and committing to have a successful session here. As well as thank you all for being a great audience today. Around 1.5 hours, you kept quest and spent your valuable time to take part in this session today, committing your valuable time. We believe you gained some knowledge from today's session. So stay tuned with us for our upcoming sessions, and till we meet again. Good night all.
Okay, thank you, and it's my pleasure.